Hi, 1S5. Welcome to this section on angles formed by two parallel lines and a transversal. Okay, so after we cover down on the basic angles, we're going to learn another three more angle properties that can help us to solve angle problems. Okay, and they basically involve angles formed by these two parallel lines and transversal. So, what are parallel lines? Okay, parallel lines are lines, infinite lines that do not intersect and they're the same distance apart. That means these two lines drawn will never ever meet each other. And they are represented by using either a single or double arrowhead pointing in the same direction. Okay, so for example here, AB and CD, they're parallel to each other. KL and MN, all right, and can up to 3 lines, 4 lines, or 5 lines. Okay, as long as the arrowheads are the same and they point in the same direction. So how do we write or represent? Okay, two lines are parallel to each other. We use this double slash, okay, to indicate. Yeah, double slash here. Over here to indicate they are parallel to. So, for example, in the diagram below, AB is parallel to CD. All right. And what is a transversal? It is a line which cuts a pair of parallel lines. Okay, it is the line transversal. It's a line that cuts the parallel line. So if we have the pair of parallel lines here, this is a transversal. It's a line that cuts it. Actually, we can define, or it's defined that the transversal cuts is the line that cuts two lines. It doesn't have to be parallel. But for our for the angles that we want to learn, all right, the properties, it has to be a pair of parallel lines. Okay, a pair of parallel lines. So the first of the three angle properties we're going to cover is called the alternate angles. So first thing definitely is the parallel lines. Okay, parallel lines. And we'll be looking out for a Z shape. So what do you mean by this? So we're going to see if there's a parallel line here. Okay, it will form this Z shape here. Right, it will form a Z shape. And the angles formed at the corner here, the orange one I'm indicating here, they will be equal to each other. Okay, they'll be equal to each other. So from the diagram here, all right, let me use a highlighter. You can actually see that, hey, there's an obvious Z shape we can see here. And therefore, we can also say that this angle B is the same as angle C. All right. Now, if we look at this diagram, there's actually another Z. Okay, but this Z is a distorted Z. I will call it a distorted Z. So how does this distorted Z looks like? Okay, it will look like this. Okay, it will look like this. These are parallel lines. And the angle here, the blue angles, are equal to each other. Okay, they are distorted. So if you actually draw out a pair of parallel lines and draw a transversal and you measure the angles, this is what you'll find and this is what you'll notice. So angle A, in this case, let me use the highlighter again and I'll use another color. This is the one you're looking at. Therefore, angle A is equal to angle angle A is equal to angle angle D. Right? So alternate angle, always be looking out for the Z shape. Next, corresponding angle. We will need to look out for, first of all, the parallel lines. Okay. And then we're looking for an F shape. Okay. And they are in the same direction. What do we mean by this? So if we look at this, if we have a pair of parallel lines like that, we'll be looking out for something like this. Right? And in the same direction, meaning that it's on the same side of the transversal. Alright, it's on the same side of the transversal. This will be the transversal, right? The line that cuts the parallel lines. Okay, and it will be on the same side of the parallel lines as well. Alright, so from here, from the diagram, we can see that there's a, oops, wrong section, highlighter. There's an F shape here. Right, and therefore, this angle W is equal to angle X. Okay, and there's also another F that we can F shape that we can notice. Let me use another color. Alright, this time around, the F shape is facing a different side. Okay, it's on facing downwards. Okay, so then angle Y will be equals to angle Z. Okay, and the short form for the reason or for the property will be as such, corresponding angles. The last of the angles we're going to cover today is the interior angles. Okay, interior angles. So this is the abbreviation. Okay, INT dot angles. Look out for the parallel lines, of course. Always look out for parallel lines. Okay, we're going to look out for a C shape and the two angles bounded by the parallel lines. So the C shape, it could be like this. So these are the two parallel lines, right? And the two angles are this one. Okay, or it could be facing this direction as well. And the two angles inside. Okay, so the interior angles, in this case, interior means inside. So inside of these two parallel lines. Okay, and they're of course on the same side of the transversal. So let's take a look here. It's a bit different from the other two that we covered so far. Okay, why? It's still two angles, but now if you look at this, is that you realize that they are not exactly the same. All right, one is will be bigger than the other. Definitely not the same, unless they are both 90 degrees right angles. So what's the relationship between these two? Okay, so this is the W and this X, these two interior angles, right? They'll add up to 180. Okay, same thing. If you can notice, there's another right angle, another interior angle. Let me use another color. Another interior angle. This C shape is facing down. You see that? And the interior angles are basically angle Y and angle Z. Okay, let me get my pen out. Okay, angle Z. And both angle Y and angle Z, when you add them up, they'll be equals to 180 degrees. All right.